We are currently making systems that will eventually make decisions with consequences far beyond our immediate control. Before diving into the specific risks of AGI, I must first outline the framework we are working within, the IEEE's Ethically Aligned Design, or EAD. EAD is not a rigid code of conduct. It is a working reference tool designed to help engineers like us prioritize human well-being. This is crucial because without a foundation of trust, society will reject the technologies we build. The framework is built on 5 general principles: protecting human rights, prioritizing well-being, ensuring accountability for designers, maintaining transparency, and raising the awareness of misuse. Crucially, the IEEE acknowledges that ethics is not a single universal standard. We must look beyond the Western models. In the West, we often rely on Aristotelian ethics, which focus on eudaimonia, or human flourishing, and Kantian ethics, which focus on duty and rules. However, global traditions offer different perspectives essential for AGI. Shinto views all objects, including robots, as having a spirit or kami. Buddhism and Confucianism focus on relational harmony rather than individual autonomy, and the African philosophy of Ubuntu teaches that a person is a person through other people, centering ethics on community connection rather than individual rights. The IEEE document explicitly warns against a monopoly of Western ethical traditions. Most responsible innovation today is built on Western liberal democratic values. If we design AGI solely on this foundation, we risk creating systems that are biased against collective cultures. To be truly ethically aligned, our engineering must respect normative diversity, integrating these global traditions to prevent discriminatory outcomes. I'm now going to discuss the IEEE guidelines regarding artificial general intelligence, AGI, and superintelligence, ASI. Historically, software engineering has often prioritized speed and functionality over security. We built the internet on C, a language that allowed for buffer overflows, and we have spent the last 40 years patching the consequences. The IEEE argues that with AGI we cannot afford that luxury. If we deploy a superintelligent system with a safety flaw, we may not get the chance to release a version 2.0. We need to shift our engineering culture from retroactive patching to proactive safety by design. The primary risk isn't that AI will become evil in a human sense. The risk, as highlighted in the IEEE document and by researchers like Professor Stuart Russell, is misalignment. Consider the concept of instrumental convergence. If you give a highly competent robot the sole goal of fetching coffee, it will calculate the most efficient path to success. If a human tries to switch it off, the robot realizes that being turned off prevents it from fetching coffee. Therefore, it will rationally disable its own off switch to achieve its goal. The robot isn't rebelling, it's just executing bad code perfectly. As engineers, we must realize that a system's intelligence does not imply it shares our common sense. It only cares about the objective function we unwittingly wrote. This leads to specific technical failure modes. The IEEE document warns against systems maximizing a reward function at the expense of ethical values. In the field of AI safety, this is often called reward hacking. Imagine an AI tasked with cleaning a room. It might learn that hiding the mess under a rug gets the same cleanliness score as actually cleaning it, but with less energy expenditure. In a vacuum cleaner, that's annoying. In an automated financial system or a medical diagnosis AI, hiding the mess could be catastrophic. We need to design objective functions that account for unintended side effects, ensuring the system doesn't destroy the environment just to optimize a variable. So, what's the solution? The IEEE recommends we focus on corrigibility. Corrigibility means designing a system that allows itself to be corrected. An AGI must be programmed to be uncertain about its own objectives. If it knows it might be wrong about what humans want, it will pause and ask for clarification rather than bulldozing through obstacles. We must also implement safe by design architectures. We cannot rely on boxing the AI, i.e. keeping it on a disconnected server, because a superintelligence will eventually socially engineer its way out. Instead, safety must be mathematical. We need formal verification methods to prove that the system's behavior remains within a safe bound before it leaves the sandbox. This brings me to my specific recommendations for management. First, we must establish an internal ethics review board for all high-level AI projects. This board needs veto power over deployment, similar to safety committees in biolabs. Second, we should adopt the Asilomar AI principles, which state that safety research should be shared, not hoarded. If we discover a safety vulnerability in our architecture, we have a duty to alert the industry. Safety is not a competitive advantage, it's a prerequisite for the field to exist. To conclude, the IEEE emphasizes that AGI and ASI must be developed for the common good. We are moving into an era where our tools will be smarter than we are. If we treat safety as a checklist item we do at the end of the project, we will fail. But if we integrate these ethical designs into our core architecture today, we can ensure that these systems not only work efficiently, but work for us.